Welcome to tutorial 21 in the Practical RF Design tutorial series. I am Dr. Prakash Sangaran and I am a Keysight certified expert. This is a 4-part tutorial. In tutorial 19, we will cover antenna introduction. In tutorial 20, we will cover antenna selection, design and optimization part 1. In tutorial 21, we will cover antenna optimization part 2. In the last tutorial, tutorial 22, we will cover antenna optimization part 3, antenna EM simulation and results and analysis. Let's continue with tutorial 21. As we studied before, a current carrying wire radiates when it's curved, bent, discontinuous, terminated or truncated. To put this theory to test, we have created this novel bent, discontinuous, terminated and truncated antenna. We hope this will effectively lower the resonance frequency and enable multi-band performance. We have to place both positive and negative pins in the schematic. The positive pin goes to the feed and the negative pin goes to the ground plane. We will see this in the layout later. When the microstrip line component tags overlaps, we must separate the component tags because we will later edit the component parameters. Editing becomes easier when you clearly see the components tags. The next step is to parameterize the design. To do that, let's first create or define parameters we want to use in the design. To create parameters, we have to go to File, Design Parameters and click on Cell Parameter tab. Here we can enter the parameters you want to use in the design one by one. It could be a lengthy process depending on the design's complexity. All variables you want to optimize later need to be defined as parameters. Each parameter has characteristics that determine how it's handled when the parameter is used. This include parameter name, value type, default value, parameter unit type, and other control attributes. Let's create a dummy parameter to demonstrate parameter creation workflow. I will create a dummy parameter named Q1 for this exercise. You need to write Q1 under parameter name. For value types, you have 4 options. It can be either real, integer, complex or string. For our design, we will leave it to real. The default value contains the default value parameter. It is recommended that the unit be inserted together with the default value in this box. The default value can be in mil, mm, cm and etc. We will use mm and we will enter 0.1 as the default value. The parameter type /unit is optional, so you can leave it unitless or assign a unit. The unit can be length, frequency, time, angle and etc. I am going to set it as length. We have to select the display parameter on the schematic option to display these parameters on the schematic. We also have to select the optimizable option to allow this parameter to be optimized. The rest of the parameters can be disabled. Finally, you need to click Add to add this parameter. As you already know, this is a dummy parameter, so I am just going to delete it by clicking Cut. As you can see, the Q1 is disappeared. The parameters I am optimizing for planar inverted L antenna are only 3 kinds. Those are width, length and separation. For simplicity, I define width as X, length as Y and separation as Z. A unique number is given at the end of the X, Y and Z to differentiate different elements of planar inverted L antenna. Let's click OK to exit the Design Parameters pop-up window. As you can see, the parameters have been inserted into the appropriate microstrip schematic components as each unique parameter is created for each microstrip component. We need to ensure the correct parameter are inserted into the respective microstrip lines. If you recall previously, we defined the default value with the unit mm. Due to this, microstrip schematic components should not have the unit on them. Otherwise, they will have double unit which will result in wrong width and length parameterization. Next, we should insert width and length parameter into the microstrip schematic component by double-clicking the component and inserting it. While inserting, the unit will disappear. Since our intention is to get rid of the unit, you can ignore this. As you can see, the parameters already been inserted. Each component parameters is inserted individually by double-clicking on it to launch the Edit Instant Parameter tab. I have given a unique number for each microstrip component width and length to identify them easily. This way, I am able to update them quickly. The ground plane dimensions are not parameterized because I am not planning to optimize the ground plane size. We have completed the insertion of parameter into the appropriate microstrip components. Next, MSUB is inserted to define layer of the PCB. This is a 2-layer rigid PCB with antenna located on the top layer. After inserting the MSUB, enable the CON1 in all the MSUB because that's where the layer is defined. CON is our top layer and CON2 is our bottom layer. These layers are defined in order from MSUB1 to MSUB2 under CON1. Since we have decided to place the antenna on the top layer, CON, nothing needs to be done because by default all the microstrip lines are placed on the MSUB1 layer. Before moving to the next step, it's a good practice to check all the parameters are correctly inserted. Our schematic is ready. Finally, we can create and update our ADS layout from this schematic. This is done by clicking Layout, Generate and Update Layout, and click Apply. The layout is successfully generated and it looks exactly like the way we want it to be. Please take note that this antenna is unoptimized antenna. Since we created our layout from the schematic, we should check if our layout is parameterized by going to EM, Components, and Parameters. Under Design Parameters tab, you can see all the design parameters that we have created in the schematic. After that, click OK to exit the Design Parameter tab. Next, we need to create a port from the pins. To do that, click on the Port Editor tab. P2 is the ground pin and P1 is the positive pin, so drag P2 to the ground of the P1 pin. We have successfully created the port now. Click Close to close the port editor. The next step is to set up the EM simulation. We will launch EM Setup and choose our preferred EM simulation settings. Momentum Microwave EM Simulator is chosen for this optimization because it requires less mesh density and time to EM simulate the design without compromising on accuracy as long as a correct port setting and mesh density are used. Let's define the frequency range and frequency point of interest. The frequency range of interest is 0.617 GHz to 0.96 GHz, 1.71 GHz to 2.2 GHz, 2.3 GHz to 2.69 GHz. The final setting is the mesh density definition. We will define mesh density as 50 cells per wavelength. It can be found under Meshed, Global, and Mesh Density. The rest of the settings are set to default. We can save and exit EM Setup now. Finally, we can create our EM model by clicking EM, Component, Create EM Model and Symbol. Click OK and click OK. The EM model can be found as the symbol under the cell. Double click to open it. I don't like the layout look-alike model created by default, so I will change it to dual pin symbol. Save it and click Exit. With this, tutorial 21 comes to an end. For inquiries, please email pragash@innovave.co or visit www.innovave.co.